Okay, so last video we finished up with the inner planets as we were looking at our tour of the solar system, and we went from Mercury to Venus, then to Earth and Mars, and now we're going to move on to the planets of the outer solar system, and we're going to start by looking at some of the moons, and specifically then the outer planets with Jupiter. We can kind of see some of the stats here about Jupiter. Okay, its length of day little less than 10 hours. Its average temperature negative 234 degrees Fahrenheit. You can see a lot of these bands of gases that move around on Jupiter. Its distance from the sun, length of its year in Earth days, just to give us a couple stats about the planet. When we look at some of these moons of some of the planets in our solar system, we see that Jupiter has a lot of very big moons, what we call here the four Galilean moons, Ganymede being the largest, followed by Callisto, Io, and then Europa. Finishing out looking at this for the moons of our solar system, Titan being the second largest moon, that's a moon of Saturn, and then Earth's moon rounds out our top five. And that kind of gives us an idea of some of the size comparisons for the moons within our solar system. And from there, we'll look back here quickly at Jupiter. And we can see here its great red spot is a giant hurricane that's been spinning for hundreds of years. Since Galileo first pointed the first telescope at Jupiter, he was able to recognize this great red spot, and it still is spinning today. It's essentially a giant hurricane or windstorm on the planet. So if we look at Earth in comparison to the size of Jupiter, we could see that Earth would fit about 3 Earths inside of this giant red spot. Some of our facts on Jupiter: emits more energy than it receives from the sun, and that's a lot of radiation energy that it emits. So it's not a very friendly, happy place for humans to go to because of this energy that the planet gives off. It is the first of the outer gas giant planets, 5th planet from the sun, largest planet in the solar system, and it's twice as much mass as all of the other planets combined. That's why its gravity is about 2.36 times that of Earth's. Jupiter also rotates faster than any other planet, like we said, just under 10 hours for its day, and it has the strongest magnetic fields of all the planets. Jupiter's great red spot is a big storm that's 3 times the size of the Earth. Jupiter doesn't have any rings, does have rings, but they're not as numerous and as easily visible as Saturn. Jupiter does resemble a star in its composition, but it did not grow as big to start fusion, and that's what it would need to happen for it to become a star. It would need to grow many times over to get to the size of a star. It's not close. Even if it swallowed up all the other planets in the solar system, it wouldn't make it big enough to start fusion. Okay, with a pair of binoculars, you would be able to kind of see this view. If you had a decent pair of binoculars and you were able to look up at Jupiter, you'd be able to see Jupiter and especially its 4 largest moons. And then we're going to focus on those 4 largest moons of Jupiter. So Jupiter has more than 60 known moons. I believe 62 of them are named. There are 5 smaller moons that don't have names yet. The 4 largest ones: Io, Europa, Ganymede, and Callisto. Io is the most volcanically active place in the solar system. Europa is mostly made of ice water. We think that because there's an icy ocean or a icy slushy ocean there, that maybe there might be enough liquid water there to support some type of life. So it would be kind of curious to kind of try to travel there and do some essentially ice fishing on Europa to see if there's anything swimming around in the waters there. Ganymede is the largest of the moons. It's actually larger than the planet Mercury, but because it orbits around Jupiter and does not orbit the sun, it's considered a moon and not a planet, even though it is large enough. Callisto is another very large moon of Jupiter, 3rd largest in the solar system, very heavily cratered body. some of the pictures here. Io, the volcanically active planet, we can kind of see some sulfur and carbon dioxide and kind of giving it that orangish yellow look. So you can see a different view of that planet, and it kind of reminds me of one of the moons used in the Star Wars movie Mustafar, where it's very volcanically active and kind of lava flowing across the surface. And that was the moon used for one of the final fight scenes where Anakin then gets turned into Vader. Just try to bring in a little Star Wars whenever we can when we're talking about outer space. We have here the moon Europa. This is the ice moon of Jupiter, so its surface very cracked and kind of frozen. As it gets closer to Jupiter, it kind of gets crushed or flexed a little bit, almost like flexing a racquetball. And the more you squeeze that, the more the surface will kind of crack open and allow water to get shot out through, but it will also generate a little bit of heat. And a lot of these moons, as they kind of orbit around, we have these tidal pulls with the Earth and our moon. These same things happen with Jupiter and its moons, but with these tidal pulls, it kind of squeezes and kind of contracts the moons and then kind of lets them expand a little bit. Well, with the ice moon, it allows for water jets to shoot up. With something like Io, it keeps it warm inside and allows it to be volcanically active. This is a side view of Europa, and we can kind of see some of those water jets getting shot out into space. So that liquid water gets kind of forced through the cracks in the surface of the moon. We can kind of see the ice covering what we think might be a liquid ocean underneath. We know that there's some liquid water from that previous picture. We could see those water jets being shot up into the space around the planet, and we think that there might be even a surface and a rocky interior similar to some of the inner planets. Here we have Ganymede and Callisto, rounding out those top 4 moons of Jupiter. Next, we're going to be looking at Saturn. Okay, Saturn, most notable feature it has are its rings. They are thousands of miles wide. In this picture, we could also see auroras produced by its electromagnetic field at its south pole. In this picture here, we have the sun kind of passing its light through the rings on the planet. Kind of gives us a neat look that we can kind of see light coming through the rings. The rings are made up of ice and dust and some rocks, and the more ice gives it a little bit more of a rainbow color, but these rings are not solid, and there's different bands. We can kind of see the different sections of rings and easily kind of separate the different parts of Saturn's rings. And again, there's thousands of miles from the outermost rings to the innermost parts of the rings. This picture gives us a little different angle of the rings, but one of the other things it does is it shows the planet Earth here. So this view of Saturn from the Cassini spacecraft gives us a little look back at this pale blue dot, or the Earth, and what the Earth kind of looks like from Saturn. Looking at some of our facts about Saturn, Saturn is the 6th planet from the Sun. It orbits about every 30 Earth years. It has thousands of beautiful little ringlets. Saturn is unique among the planets because it has a lot more rings than any other planet. And the colors of those rings kind of give it a rainbow effect, especially where we get a lot more ice and dust going through that planet. Looking at a little different view here of Saturn, we can kind of see its rings, how thin they are. Like we said, they're thousands of miles wide. In terms of their thickness, they're only a few meters thick. And here we also see, in this other view of Saturn, its moon, Titan. Okay, second largest moon in the solar system, largest moon for Saturn, has a very thick nitrogen-rich atmosphere, and we have some lakes on its surface. So that kind of makes it a little curious for us that maybe we need to kind of explore and look into this moon a little closer, like we were talking about with Europa. Some of the things that we notice here, more some facts about Saturn and its moon. Like some of the other gas giants, Saturn mostly a massive ball of hydrogen and helium. Okay, less moons than Jupiter, but not by much. Okay, we look at it again, Titan as being the largest and most interesting of the moons. It affects the orbit of nearby moons, hides its surface with a thick nitrogen-rich atmosphere. Its atmosphere similar to Earth's atmosphere from long before biology took over on Earth, and doesn't have a lot of oxygen and things like that. Some other stats here for Jupiter, looking at its distance, it's a little bit more than, like we said, 30 years or so for it to go around the sun. Its length of day, a little bit over 10 hours, so it spins fast, but not quite as fast as Jupiter. So we can kind of see it spinning there. We get an idea of its rings. Okay, Saturn's beautiful rings divided up into 7 distinct areas. The sections consistent with ice particles. The size and structure of the rings partly produce a gravitational influence on several of Saturn's moons. So it gives you some information there to add to about Saturn and its moons. Okay, now we're going to look at Uranus as the next planet. We notice with Uranus it does have rings, and the rings kind of go in a north-south or up and down instead of across the planet. Uranus is one of the few planets that's tipped on its side. We believe it was from a collision with an Earth-size object. So we can kind of see here in this other view some of the different moons and objects going around Uranus, named mostly after Shakespearean characters. Some of our facts for Uranus: 7th planet from the Sun, takes about 1 human lifetime, or about 84 years, to orbit once around the Sun. The only gas giant planet whose equator is at a nearly right angle to its orbit. A collision with an Earth-sized object may be able to explain its unique tilt. It has more methane in its atmosphere, or clouds that make it up, than hydrogen and helium, and that methane gives it a little bit of a blue-green tint. That's why it looks a little bit different than Saturn and Jupiter. It has 27 planets, or 27 moons or satellites orbiting it. So we get a little bit further look here. We think that it has a solid core holding the gases kind of together. We said it has a little bit more methane than some of the other planets that we were looking at previous to it, and that's what gives it that blue-green tint. And we kind of get a look at a little bit of the inside there of Uranus. Going on to Neptune. Okay, Neptune, last of the gas giant planets, a dark, cold planet whipped by supersonic winds, more than 30 times as far away from the Sun as Earth. The planet takes almost 165 years to make one orbit around the Sun. We refer to it as a sister planet to Uranus, similar to we look at Earth and Venus as being brother-sister planets. We kind of look at the same thing with Uranus and Neptune. Also made of some frozen methane, giving it that blue look. It's considered the ice giant planet. First planet located through mathematics. When we looked at the orbits of Uranus and we realized there's something not quite right with its orbit, we did some mathematical calculations, or astronomers did some mathematical calculations, and found that there should be some planet further out there than Uranus, and when they pointed telescopes in that area, they were able to find Neptune. It has 13 satellites or moons. So now we're going to talk about the criteria to be a planet. So we look at these planets and we say, well, there's got to be something there to distinguish planets. I mean, other than just objects orbiting the Sun. There's a lot of things that orbit the Sun that we don't consider planets. They have to be big enough to be squashed into a round ball, so that kind of eliminates a lot of asteroids, but Pluto fits a lot of those first two categories. But in 2006, when we found a lot of other objects in the Kuiper Belt that were similar to Pluto, we said we have to kind of change this definition, and that's where we say we get this third definition of what a planet is here, or the third criteria, that it must have cleared other objects out of the way of its orbital neighborhood. To clear a path, the planet must be big enough to pull the objects into either an orbit around itself or slingshot them into other places in space. And from that, then we kind of get to some of our other objects. There's some images of Pluto, before and afters, and we kind of get to Pluto and some of the dwarf planets. And that's it for this video.